Good day and welcome back to Everything Mathematics. And today I'm going to show you about multiplying. In this way, I like to, well, I don't know, I like to call it an unconventional way of multiplication because usually it's not what they teach us in school. But if you learn this method here we call the lattice method, I believe it will take away all your multiplication troubles away. And you will feel encouraged to multiply even big numbers even if you cannot use a calculator. So this is why I like the lattice method, because I noticed, or from the very first day that I learned this, I always felt motivated to do multiplications of course, more than 2 digits. So let's look at, sorry about this. Let's look at what I consider the traditional method first, and then I'll quickly go into the lattice method and we're going to do some quick examples. So traditionally, if we were to multiply, let's say 936, and we want to multiply that by, let's say, maybe 32. Traditionally, of course, we told you just put the big number on top. It doesn't have to be because it's multiplication, but normally that's how we do it. And then you multiply and you put your 32 there and you start. You use your first digit or the digit that is in a units place and you multiply that by the top. And again, I'll just, sorry, I'll just do it. So 2 times 6, we say that's 12. We cross out the 2, we put the 2 here. 2 times 3, that is 6, but this 1 from the 12, that would make it 7. And 3 times 9, that should be 27. Good. And that wraps up the 2 row or the 2 multiplication, call it what you may. And then we go to the second row, and there we put a 0 to start up that row, and we start immediately below the 3. And then we go again. 3 times 6, that will give us 18, and we put the 18 because of course we only use units in place values. Then we go 3 times 3 is 9, but then this 1 from the 18, that will give us 10. And of course we don't put the whole 10, we just put the 0. So we could cancel that there. And then we have, oh my goodness, I made a mistake. I just noticed I made a mistake a while ago. Let me correct that error. I jumped from 3 to 2. That's a mistake. Oh my goodness. It's supposed to be 2 multiplied by 18, and that's supposed to give us 2 multiplied by 9, sorry. And that's supposed to give us 18, not the 3. Sorry about that. So it's 2 multiplied by 6, 2 multiplied by 3. So even this is a mistake here. Oh my goodness. Okay, here what? Let me start over this whole thing. Let me start over. I don't want to confuse you. I overlook the 2 and I look at the 3. So let me start over. Starting with the 2. 2 times 6, that will give me 12. So I cross out the 2 and I put it here. Then I have 2 times 3. That will give me 6. And then plus 1, that will be 7. Okay, I think I had that. And then it's 2 times 9. That will give me 18. So I put my 18. Then I put my 0 and I move on to row 2 with the 3. So 3 times 6, that would be 18. And notice, this, what I just did there was an honest mistake. But those are, I don't want to call it flaws, but those are things that could honestly happen even to the best of us when we're doing this method. This is not likely to happen with the lattice method, and you will see why just now. So don't think I'm doing this by spite. Honestly, that was an honest mistake. And then we go, 3 times 6 is 18. So I cross out my 8 and I put it here. 3 times 3, that is 9. Plus this 1 from the 18, that will give me 10. So I just put the 0. And then 3 times 9, that will be 27. And then we have that 1 from the 10. So that will make it 28. Good. And then I just add those 2 values or these 2 places. So I have 2. Then I have 7 plus 8. That is 15. So I put my 5. 1, 8 plus this 1 here. That will give me 9. 8 plus 1. That is 9 again. And then just the 2. So notice that my answer here is 29,958. And as I said, this is traditionally how we are taught to multiply. Let me just tell you now about the lattice method, or how do we go about doing the lattice method, and how do you think, or how perhaps you could consider exploring this option in the future when it comes to multiplication. So to do the lattice method, of course, the first thing you need to do is draw a triangle, well, rather a rectangle, not a triangle, it's a quadrilateral. So you have a quadrilateral, and you determine how much rows by how much column. And how much rows by column is honestly solely dependent on how much numbers you are multiplying. If you look at the numbers that I'm multiplying here, I have 3 digits by a 2 digit. So that means I'm looking for a 3 by 2. Good. So I'm looking for a 3, good, by 2. Oh, I don't like how this second line come on. Right. So I'm looking for a 3 by 2. Don't mind my crooked lines. Good. 3 columns because I have a 3-digit number, and here you could say 2 rows because I'm multiplying by a 2-digit number. And then once you have this rectangle and you have your mini squares, you take each square and you split it with a diagonal in the middle. Each square, you split it with a diagonal. And that's all. This is where the magic starts. And now you have a 3-digit number. So we have 9, 3, 2. Make sure that's the number I'm multiplying. No, it's 9, 3, 6. So this here is supposed to be a 6. Good. 9, 3, 6. I'm teaching you the method as I do the same example. And here we know, of course, we have 3 and 2. And here the multiplication process goes now. You're multiplying this unit, this 6 here, by this 3. This 3 by this 3. This 9 by this 3. And the values goes right there. So let me do this one as an example. Let me use color code so that you'll see the difference. So 9 multiplied by 3, that will give me 18. 9 times 3 is 18. Then I'm doing 3 times 3, that is 9. But because 9 doesn't have any tens place, we replace the tens place with a 0. So 0, 9. And then we have 9 multiplied by 3, and that, of course, will give me 27. And then we go again. 9 times 2, that will give me 12. 9 times 3, 0, 6. Because 9 times 3, 6. There is no place in the tens place, so we replace it with a 0. We just fill it in with a 0. And 9 times 2, everybody would know that is 18. So there the multiplication process is finished. And now, to wrap up the lattice method, all we need to do is add, come down each diagonal row. So in other words, we coming down this way. We add in this way. We add in this way. We add in all the numbers this way. We add in all the numbers this way. And of course, we add in all the numbers this way. And once we do that, the process is all finished. So let's add across each diagonal. So starting with the 2 here. The 2 is alone, so we just bring down that 2, and that will give us 2. Then we add in this diagonal here, so that will be 8, 1, and 6. 8 plus 1 is 9. 9 plus 6 is 15. So guess what? We put down the 5, and the extra 1, we throw it anyway in the other row. So let's put plus 1 here. That's the 1 from the 15. And remember, we added. So now we add in this extra 1 here. So 9 plus 1 is 10. And 10 plus 1 is 11. 11 plus 8 is 19. So again, we put a 9 there, and we throw in plus 1 there from the 19. And we continue. 7 plus 1 is 8, and 8 plus 1 is 9. So we put 9 here, and just the 2 to come down alone. And this here will be our result. So our result here will be 29,952. Did we get that answer earlier? Yep. Same answer we get. 29,952. But notice, which one do you thought was more straightforward? Or which one you thought took me less than? I don't know about you, but to me, I thought I did it a lot faster using the lattice method. And for the lattice method, there's hardly any room for error. And the beauty about the lattice method is, so long as you know, and again, this is kind of bad news, but good news. So long as you know up to your 9 timetables, you have no headache, because you will never be finding more than 2 units in one place. Never. The highest will be 9 times 9, and that is 81. You will never find a scenario where you will have to put 10 times 10, 100. Because notice, this method will always hold 2 digits. And no matter how you break down a number, you always multiply digit by digit at the end of the day. So let's see if we could do another example. And this could work with any amount of numbers. So let's imagine we're multiplying a 2 by 2 number. So imagine we're multiplying 19 by, let's say, maybe 46. It could work with this now. But now, notice, because we have 2 digits multiplied by 2 digits, our rectangle will be different. Well, in this one, you could say we're calling it a square because it's like a square, 2 by 2. So again, you draw your shape, and then you split it, 2 by 2. And I must say, it does not matter where you choose to put your 19 and your 46. The answer will not be affected. So for example, let me just split it into diagonals, 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 diagonals. Some people believe that, okay, this first digit here, 19, has to come on top here. No, that's not true. It could go any way. And that's one of the properties of multiplication. We know that multiplication is commutative. As a result, it does not matter whether you put one number before the other or the other before the number, you will get the same answer. In other words, all I'm saying here is that 19 multiplied by 46 is the same thing as 46 multiplied by 19. And because of that lovely property, when you're doing the lattice method, you don't have to hurt your head as to which number you put where. If I must go back to the second example here, the same thing could have happened. You have 3 digits here and you have 2 digits here. Nobody says the 2 digits have to be on this side here or this side here. If you wanted, you could have put the 2 digits on top. But of course, that simply means that your shape would have been shifted. So that means you would have had something like this instead. And that's okay. That would not affect the answer. You would have something like this instead. You see? So the 2 digits would have gone here, 36, and your 3 digits would still be 9, 3, 6. And of course, you split it. You split each square accordingly. And trust me, you could take my word for it. Of course, if you have time, you could do it. When you do this and you still go the same process, you will end up with the same answer, guaranteed. Trust me, I played with this method a lot. At first, I like it from the first day I learned it. Good. So let's do this one now. So here we go, 6 multiplied by 1, that will be 0, 6. 4 multiplied by 1, that will be 0, 4. 6 multiplied by 9, 6 nines are what? 48, I think? Yes, it's 48. So that will be 4, 8. And 4 multiplied by 9, that should be 36. So 3, 6. And once we finish with the multiplication process, it's just to add along the diagonal. You're adding along the diagonal. So here we just have 8, so we just put on our 8. The second diagonal here, we have 6, 4, 6. 6 plus 4 is 10. 10 plus 6 is 16. So I put on my 6 and I add my 1 to the next diagonal or to the next row, if you want to call it like that. And then we have 4 plus 1, that's 5, and 5 plus 3, that is your 8. So our, 0 is 0, so 0 if you want to put the number 0, but that here is just a placeholder there. So then your final answer here would be 868. So in other words, 19 multiplied by 46 is equal to 868. Very, very easy. I don't know about you, because again, as I said, it basically comes down to knowing a digit by a digit. Oftentimes when students are asked to do this way, well, in fact, they're not asked to do this way. They are taught to do it this way. So that's the only thing they tend to know to do. And somehow when they do this, I've seen a lot of students, sometimes they struggle by the time they reach the second row, for example. And let me just do this as a reference. So 6 times 4, 6 times 9, we know we get our 48. So we put our 48. And then 6 ones are 6, and then you add 4 here. So you're getting 108. And I've seen a lot of students, for whatever reason, when you go to the second row now, 4 times 9, they tend to always start at the end here. They always start at this corner here. And that's a common mistake. And I don't know, maybe it's a flaw in the teaching or a flaw in their understanding. And as a result, they always start from the end. They always believe they have to start from the end instead of starting immediately below the 4. Of course, we also have the other issue where sometimes students don't work neatly. So then they don't come down. The rows and the columns don't look neat coming down the line. And as a result, sometimes you put the number in the wrong place. So the lattice method of multiplication saves you from all that trouble. Other than that, it is cool, it is very easy to understand, and it is fast. It is very fast to do. I literally perform this, any 2 digits, 3 digits plus operation, I quickly use the lattice method, and it saves me a lot of trouble. Imagine if we're doing a 3 by 3 now. Look at how the lattice method makes it look so easy. So imagine we're multiplying something like 314, and we want to multiply that by, let's make it even bigger, man. Let's look at 3 by 4. 1,200 and let's say what? 45. 1,245. Trust me, a number like this will make children see a lot of trouble when you're multiplying, as I call it, in the traditional method. Watch how easy the lattice method makes this big, seemingly big number easily to be multiplied. So here we have a 3-digit number multiplied by a 4-digit number. So again, you have to remember how the rectangle will look. So we're looking for 4 by 3. So I usually like to put my bigger number at the top. That's personally me. But as I showed you a while ago, it does not matter. You could put it any way you want. So I will do 4 by 3. So just take your time. It will take some time to set up. So I know I need 4 columns here. Good. That will be for my 4-digit number. And then I need 3 digits, 3 columns, 3 columns. Good. And remember then, you split each one in the middle. I think there's a song like that. Split in the middle. So you draw a diagonal along each one through the center. Of course, you always try to work as neat as possible. Right now, I'm doing this on the computer and I have to do it freehand, so bear with me. And this is my setup. So my setup is finished here. And now I put in my digits. So the 4-digit number, of course, will go up here. So 1, 2, 4, 5. And my 3-digit number will go where the 3 rows are. So that will be 3, 1, and 4. My setup is now finished. And now I do my multiplication. So let's multiply. And this is really easy. It's like single digits, operating with single digits. And then we add. So 5 times 3, here I will have 15. 4 times 3, I will have 12. 2 times 3, I would have 6. Watch how easy this process is. And 1 times 3, that would be 3. Once you understand the pattern and the order in which you're going, it's really a walk in the park, like truly. 5 times 1, that is 0, 5. 4 times 1, that is 0, 4. 2 times 1, 0, 2. And 1 times 1, 0, 1. And then I'll do the last one. 5 times 4, that is 20. 4 times 4, that is 16. 2 times 4, that is 8. And then we have 1 times 4, that is 0, 4. Wow, look at that. The multiplication process is over. That's it. And now for the last thing to do is to write down the answer. And again, it could seem tricky when it's longer, but again, just remember the concept. No, you're adding along the diagonals. You're adding along the diagonals. That's all you're doing here. So the first row here, we start with 0. So there's just 0 in that diagonal. Then the second row here, we have 6, a 2, and a 5. So 6 plus 2 is 8. 8 plus 5, that is what? 8 plus 5, that's 13. So I put 3 and I add a 1 plus 1 in the next row. So 5 plus 1, let me put the plus here so you don't think that is 15. 5 plus 1 is 6, plus 4, that's 10, plus 1, that's 11, plus 8, that is 19. So again, I just put on my 9 and I put plus 1 in the next row. It doesn't matter where you throw it, so long as you identify that you're adding an extra 1. And then we add in now 1 plus 2, that is 3. 3 plus 1, that is 4. 4 plus 2, that is 6. And 6 plus 4, that is 10. So again, I just put the 0 and I throw my plus 1 in the next row, somewhere in the next row, or the next diagonal, however you may see. So here we have now 6 plus 1, that is 7. 7 plus 2, just add this to one time. 7 plus 2, that is 9. And in the last row here, there is just a 3. So I bring down my 3. So look at that. My answer is 390,930. Wasn't that fast? Wasn't that seemingly easy? I am pretty sure this is a lot easier than multiplying these two numbers, coming up with, so we have x asterisk, it doesn't matter, x, then you're multiplying that, x asterisk, 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 asterisk. So we have 4 digits multiplied by 3 digits. Yes, we're multiplying that. Remember, we would have ended up with 1, 2, 3 rows. And then we would have had to add these 3 rows. I know a lot of students will get caught up along this part. But you see, that cannot really happen with the lattice method. So as I said, it's one of the methods that I think is very cool to multiply. And as I said at the beginning of the video, if you learn to multiply using the lattice method, trust me when I'm telling you, whenever you see 2 big numbers to be multiplied, you would not feel intimidated or feel that you need to take a calculator to multiply them. Because it's honestly really cool and easy to come up with your table, a 4 by 3, a 3 by 2, a 4 by whatever. You split each square into a with a diagonal, and then you just multiply unit by unit, 5 by 3, 4 by 12, 2 by 3, right? So I think I'll stop there for today. Maybe in the next video, I could do some more examples if you so desire. CXC exams are around the corner here in the Caribbean. So of course, if you so wish, you could recommend or suggest maybe a CSEC past paper here that I can do, and I could easily go through it, and we could go through it and see the answers together. So until then, you take care. Subscribe as always if you haven't as yet. Share this video. Like, of course, if you liked it, and see you in the next one. Until then, you take care.